All right, this is questions 11 through 15 on the SAT math section. Number 11, which of the following equations is the most appropriate linear model for the data shown in the scatter plot? Of course, linear tells us it should be of this format, y equals mx plus b, where m is the slope. And quickly we look at this line. If we read it from left to right, the slope of this line is negative. So I know it can't be C and it can't be D because the M value has to be negative. Of course, B is the y-intercept, where this graph intersects the y-axis. And we can see it intersects the y-axis way up here, right around positive 10. So we know the answer has to be B because that is the answer choice that has a y-intercept really close to positive 10. Question 12, the graph of y equals f of x is shown where the function f is defined by f of x equals 8x to the third plus bx squared plus cx plus d, and a, b, and c and d are constants. For how many values of x does f of x equal 0? So we want to find how many values of x does this make this function equal to 0, or in other words, where is the y value equal to 0? Well, the y value is equal to 0 anywhere along the x-axis. So we're looking for the x values that have a y value of 0. So that's these 3 points right here. So that means there are 3 values of x that make this function equal to 0. Question 13, Vivian bought party hats and cupcakes for $71. Each package of party hats costs $3. Each cupcake costs $1. If Vivian bought 10 packages of party hats, how many cupcakes did she buy? So I'm going to circle this because that's 10 packages of party hats, and then I'm going to circle the $3. because those go together. So she altogether spent $30 on hats. Well, she spent a total of $71 back at the beginning. So that means the difference between these two of 41, that means the last $41 have to be on the cupcakes. And since each cupcake costs only $1, that means she's purchased 41 cupcakes. What is one of the solutions to the given equation? All right, I'm first going to show you how to solve this in the graphing calculator just because it's quicker. So x squared, I'm going to change all these to x's. It doesn't matter which variable we use. And we graph, and we can quickly see there are going to be, there's two solutions, but the graphing calculator only gives us one. The good thing about this problem is they only want one of the solutions. So one of the solutions in this problem is 2. So we could stop there, but mathematically, I want to show you how to get that answer using a little bit of algebra. We would factor this question. So we're going to factor this into two factors. Z and Z go in these first two slots. The last two slots of these factors are two numbers that multiply together to give us negative 24. I always like to list these first. Let's forget about the negative sign for just a second. So of those combinations, they need to multiply together to give us negative 24 and add together to give us 10. At first glance, you might think 4 and 6 might work because 4 plus 6 is 10. But since these numbers have to multiply together to give us a negative number, it can't be positive 4 and positive 6. So it has to be 2 and 12. So think to yourself, is 12 minus 2 10 or 2 minus 12? Of course, this is the combo that works. And then the last step, we've got the factors written, but they want the solution. So we're going to use the zero product property. And you can see pretty quickly, we're going to get the solution that the graphing calculator gave us. But the graphing calculator trick was a lot faster. And then you can see why this other one didn't show up, was our window was not expanded large enough on the graphing calculator. Again, keep in mind, they only want one of the solutions. Bacteria are growing in a liquid growth medium. There were 300,000 cells per 1 milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter? Well, there'll be 15 hours after the initial observation. So 15 total hours, but if we divide that by 3, we get 5. So that means we have a doubling pattern that has occurred 5 times. So the quickest way to do that is just take this number and double it 5 times. So we could multiply by 2 in the calculator, but let's just do this the old-fashioned way. 300 doubled once is 600, doubled twice is 1200, doubled 3 times 24, doubled 4 times 48, doubled 5 times 96, with all the added zeros on there that we took out